All right, this is lesson 4 systems of equations. So again, this is a throwback to Algebra 1. I hope you remember how to solve these systems. There's three methods: graphing, substitution, and elimination. So we'll look at those three today in the goal. So just refreshing memory again, what is a system of equation? Of equations. It just involves more than one equation with more than one variable. So this pair of equations here makes a system of equations. And the solution then, it could actually be more than just two equations. You could have systems of 3, 4, 5, 10, 15, 20 equations. So, but we won't get into that right now. Maybe in a linear algebra class in college. But the solutions to a system in two variables, x and y, is an ordered pair. We're looking for a point x, y, that when we plug them into these two equations, it makes both equations true. And that's what the solution does. It makes the equations true, both of them. So you can solve systems using one of these methods. We could graph, we could use substitution or elimination. And it's important to remember that some systems don't have any solution at all. Some are going to have multiple solutions. So there's a variance there, all right? So here's hopefully a very simple one for you. Example 1, find the solution. Someone has graphed two lines, and the solution is simply this point right here. 1, 2, 3, 4, 5, 6. So that's 7, and then up 1, 2, 3, 4, 5, 6, 7. Oh, that's 7, 7. So the solution is 7 for x and 7 for y, and if we knew the equations, those two would solve each equation, making them true. Okay. Substitution method. Well, you're going to use this method if one of the equations happens to be solved for x or y, meaning one of the equations says either x equals, or you've got one equation that says y equals. Nothing else on that side of the equation except the x or the y. So you substitute the expression from step 1 into the other equation for that variable. You solve the resulting equation, and then substitute the value you get from step 3 back into the equation in step 1, and then you write your solution as an ordered pair. So hopefully you remember how to do that, and we'll do one here to help you remember that. Okay, so if you notice, I'm going to choose substitution for this because here I've got y equals. So I have a replacement for y. In place of y, I'm putting this other side of the equation, and I'm going to use this second equation to do that. So I'm going to go 7x plus 2, and that's where the y would be, right there next to the 2. But instead of the y, I'm going to put in this negative 3x plus 3. And I've just substituted. Now look, do you see any y's in that equation? I don't either. And so I can solve it. There's just one variable there. First thing I need to do is distribute. I'm going to leave the 7x alone, and this positive 2 times negative 3 makes negative 6x, and the positive 2 times positive 3 makes positive 6, and bring down my equals 1. Now these two are on the same side of the equation. I don't need to change any of the signs. I don't need to do anything opposite. I just say 7x minus 6x is 1x. And then I've got to get the x by itself, so I better subtract 6 from both sides. That's going to give me negative 5. One good guy and 6 bad guys. Bad guys are winning by 5 on that one. Now go back up to step 1 here, where you started with that original equation, y equals, and now instead of putting in the x, what goes in place of the x is what x equals, and that's what we got was negative 5 down here. So y equals negative 3 times negative 5 is positive 15 plus 3 makes 18, and my solution is negative 5 comma 18. Those two values, when plugged in, make both of those equations true. Okay? You want to try one? You give this one a try. Okay, I'm going to take 2x plus, here's where my y was. But instead of y, I'm going to put in 2x plus 1. Nothing to distribute. This is just a 1 here. 2x and 2x make 4x. I'm going to subtract 1 and divide by 4. And x is negative 2. Come back up here, y equals 2 times my x value, which is negative 2. So 2 times negative 2 is negative 4. And negative 4 plus 1 is negative 3. And my solution is negative 2, negative 3. Okay. Elimination. Well, are the equations in the same order? Well, that's when we use elimination, when they're in the same order. If they're not in the same order, you can just put them in the same order using, inverse operations, okay? Now, the key is to get one of the variable pairs to be opposites of each other. Like, we need one to say negative 3 and the other to be positive 3. So like negative 3x and positive 3x, or negative 5x and positive 5x. If they're not multiples of each other, or if they're not opposites of each other, you're going to multiply one or both equations by something to create those opposites. And then you combine the equations. That particular variable that had the opposites will be eliminated. That's the title, elimination. Solve the resulting equation and then substitute it back into either of the originals. And you're going to get your ordered pair, your solution. Okay? So here we go. Look at this. I've got a 2x and a 2x. They are not opposite, but negative y and positive y are. So this is ready for me to do the elimination. I don't need to create opposites. I already have this pair as opposites. So I'm going to just combine them like this. 2x and 2x make 4x. Negative y plus y, they cancel each other out. Negative 1 and negative 7 make negative 8. That's the resulting equation. I solve it by simply dividing in this case, and I get negative 2. Now take either equation. I'm going to take this one because it's got more positives in it. But I'm not going to write x. Instead of x, I'm going to put a set of parentheses. Plus y equals negative 7, because I know what x is now. In place of the x, I'm going to put a negative 2. That's negative 4. And then I'm going to add 4 to both sides. Negative 7, that's a 7. I know, it looks like something. I don't even know what it looks like. Negative 7, and that looks like a y. Negative 7 plus 4 is negative 3. So I got a negative 2 and negative 3 is my solution. Okay? You try this one, or let's try it together, actually. Would it be easier to get 3 and 7 to be opposite, or 1 and 2 to be opposite? Because I got a 1 in front of the y and a 2 in front of the y. Which one would be easier to make opposites with? Well, I can't think of anything to multiply 3 by to get 7, except maybe 1.5, or what, 2. I don't even know. 3 times something, yeah. I don't even know what that is. It'd be 7/3, I guess. So I'm going to do something with the y's. I'm going to multiply this top equation times negative 2. And that's going to make this y term a negative 2y, and then it'll be opposite the positive 2y. So negative 2, I got to multiply the negative 2 by everything, though. I can't just do it times the y term. So negative 2 times 3x is negative 6x. And then negative 2 times 1 is negative 2y, and negative 2 times 3 is negative 6. And I'm ready to combine. These two are opposites, and they are going to cancel each other out. 7x minus 6x is simply 1x. 1 minus 6 is negative 5, and x is negative 5. Now take either of the equations. I'm going to take this top equation, 3x plus y equals 3. But instead of x, I'm putting in negative 5. And 3 times negative 5 is negative 15. Plus y equals 3. Add 15 to move it to the other side of the equation. 3 and 15 make 18. My solution is negative 5, comma, not negative, positive 18. Okay? You can always check your solutions by plugging it back in. Like if I take the second equation now, and I said 7 times negative 5 plus 2 times 18 equals 1. Well, that's negative 35 plus 36. Does that equal 1? It sure does. Okay. All right. You're going to find some of each type in that Delta Math assignment there.